Welcome to the Rich Report, a podcast with news and information on the world of big data. Today, my guest is from kCura. We have the Chief Strategy Officer, Jay Leib. So, Jay, welcome to the show today.
Well, thanks, Rich. I appreciate it. So let's kind of talk about the agenda, what we're going to discuss in this webcast today. So first, we're going to kind of talk about the increase in big data and how it affects e-discovery. Next, we're going to talk about probably one of the most buzzworthy topics out there. It looks like you can't open up a trade magazine or even publications like Fortune and Forbes magazine without talking about computer-assisted review. So we'll talk about that a little bit. We'll talk about return on investment using a computer-assisted review workflow. We'll talk about some of the success stories we've seen out in the field from a kCura perspective. And where do we go from here? Does that sound pretty good?
That sounds great. Go ahead.
Great. So let's kind of talk about the increase in big data. That's like the hot topic when you talk about the corporate environments. So how do we define big data? Well, big data is essentially all the content that's going on in the enterprise, the structured data that is happening in their big databases, and the unstructured data, which is the emails, the Word documents, the Office files, everything that employers are allowing their employees to create. It's essentially a golden era, in my humble opinion, of content creation when it comes to the workplace. You have multiple devices, from your smartphones to your tablets. You have your mobile sales teams that are able to work on all sorts of content. And really what's happening there is that we're seeing that the enterprise, it has overload of information. And what they're saying is that all that unstructured content is taking up about 80 to 90% of their data store. And not only do they have all this content, there's a huge amount of duplicity that's going on there, meaning that I'll make an email, I'll copy it, I'll have it on multiple devices, I'll send it to multiple people will make small changes to it, send it back, have distribution lists. And what's happening here is that there's just a glut of all this data, which is fine. That's fine for the enterprise because they want their employees to be able to work with this data. But what's happening is there is a downstream effect when it comes to electronic discovery. Electronic discovery is the time when an event happens for a corporation. Maybe they are involved in some kind of investigation launched by a regulatory agency. Maybe they have been somehow they've been injured metaphorically by another company and they want to sue. Or maybe they themselves have been sued. Or perhaps they're in an industry that's highly regulated and they have to keep certain records by process of the laws, restrictions, and regulations of that industry. So all this impacts that the more data you have, the more and higher amount of time that you're going to have to work through and wade through these documents to decide if they in fact are part of your, if they're relevant to what you're looking at, if it's an investigation or if it's some kind of civil action or regulatory action. So with Relativity, we are it's an electronic discovery application. It's made by kCura, and essentially what we're seeing from our customers is that our 100 largest cases that were housed in Relativity, the median case size grew from 2.2 million documents in 2010 to 7.5 million documents in 2011. So in a one-year span, our 100 largest cases grew from a little over 2 million documents to 7.5 million documents. So you can see just there that's a blip on how big this data explosion is really happening. Next, our 5% of our largest cases, the median case size grew from 2.1 million documents to 3.5 million documents. So again, we're having over a million document increase in our top 5% of our cases. And finally, our largest 10% of our cases, the average case size went from just 700,000 documents in 2009 to 1.8 million documents in 2011. So your average kind of bread and butter type cases have significantly increased in the amount of records and data that's contained within them, which means that when you have different groups that have to go through these documents and decide does this meet the obligations of the requesting party, be it an investigation or regulatory agent effect or civil litigation? That's a lot of time and money to wade through documents that may or may not be relevant to their case, or could be even duplicative to what they already have. So we've been talking about e-discovery. We've been talking about big data and documents. So let's kind of break down the different phases of e-discovery, and then how does big data really impact things. So this model that I have up here is called Electronic Discovery Reference Model. That was designed by the EDRM organization, a nonprofit group that really wanted to talk about the different phases of electronic discovery. Now, this is organized in a distribution that doesn't take into account the actual pricing and effort impact of each phase. So if we look at it from a different perspective, like what is the most expensive aspect of electronic discovery project? We look at it slightly different. So this diagram is taking, in effect, the cost and effort and time considerations with a electronic discovery project. Is an extremely manual procedure to wade through documents, some of which are relevant, many of which are that are either just spam or duplicative of other documents, or documents that are not relevant really to the case. Why is it so much bigger? Because again, you have attorneys, you have forensic investigators, you have professionals in the legal space, all doing human review on these documents that really it's a small percentage that is actually relevant to the case. So what kind of technologies can we use to combat this? So in relativity, we're using an engine called LSI, latent semantic indexing, which basically is a fancy way of saying we index all the words in your case, find the relationships, the latent relationships between words and documents. And so when you have a document, you say, this is the document that's important to my case, you can go ahead and find similar documents to that. So it's kind of like if I use Pandora for my music and I say, I really like this song, bring me more like these. Or if I use Netflix, I say, hey, I really like these types of movies, can you find me others like it? It brings me movies that are similar to it. Or Amazon, when I go and shop on Amazon and I buy some kind of book, it suggests other books or other things that I may like that is comparable. It's really bringing in the associations between documents back to me. It's also telling me things that I think are not relevant. It's also letting me know, hey, this bucket of documents is most likely to be not relevant as well. So how does that translate? Well, that translates into extreme efficiencies as far as speed goes. If I know the path I'm going to go because it's suggesting more documents, I can go through it much faster. And if I know the documents that are most likely not to be relevant to my case, I can either choose to look at those later on in the case downstream, or I can choose to not look at those at all, which could be a tremendous cost savings. So in our relativity assisted review workflow, we've designed a workflow that will give you leverage the expertise of the domain experts, the professionals. We'll take into account this analytics engine that's very powerful. Then we also put a statistical validation phase in the process as well. So when you say, hey, these documents are most likely not relevant, you can use statistical modeling to decide, do I feel comfortable that these documents are not relevant? I have math behind me. So let's take a look at kind of the computer-assisted review workflow. So it starts with a kind of a basic process. Get some documents. These documents could be documents you know already are relevant to your case or to the investigation. Or these documents could be completely random. You just ask the computer, hey, give me some random documents from across my entire document universe. Next, you just have the reviewers go ahead and review these documents. So you first identify these documents that are either relevant or not relevant. You tell the reviewers, hey, decide if these are relevant or not relevant. And the computer is learning at this point. The brain is being trained to understand what are the kind of documents that I think are relevant, what are the kind of documents that I think are not relevant. Much like when I make my purchases on Amazon, or when I ask for movie suggestions on Netflix by telling it other movies that I like, it's doing the same thing. So we subjectively review the sample set. And then what we do is we push the button to say, computer, go ahead and go and classify all the other documents in my universe to see if it matches the requirements I've already put out there. Is it relevant or not relevant? So when it goes ahead and finishes that process of saying, okay, we know what you like, here are documents very similar to that, and here are documents we know you don't like, and here are documents very similar, you go ahead and have a validation phase. Use the statistical sampling to go ahead and measure out how many mistakes the computer has made. Is the computer making accurate decisions, or is there mistakes? If the mistakes are too high, maybe the first go-around, it suggests documents that are nothing like the documents you have had before. You tell the computer saying that it made mistakes, and it learns from the mistakes because you retrain it. So then you keep continuing this process iteratively till you get the results and the mistakes out of the system, or at least as low as you feel comfortable with as far as a review team goes. So it's an iterative process. It's very, very easy, though. So let's kind of translate this into what does it look like in a hypothetical real-world situation? How does this translate into savings? We have this big data. This enterprise has a lot of data. An event happens. They have to review a lot of documents in the process of e-discovery. And how can we use this computer assisted review workflow to save time and money? So in our hypothetical world here, let's say we start with 1 million documents. Not uncommon nowadays. So what we do is we first grab that first set of documents, 1,000 documents we'll use as an example. We'll call this the orange round. And we have the humans go ahead and review these documents. Responsive, not responsive, relevant, not relevant. They go ahead and they decide which documents are the ones that they really want to see and which documents are the ones that are not applicable to this case. From there, the computer learns what documents are good and which ones are the ones that it doesn't want. And it goes ahead and classifies the rest of the universe. And so from here, we get 3 buckets essentially. We get a bucket that says responsive. These are the documents that I want for my case. And it's going to classify out about a little under 300,000 documents. From there, it also has another bucket that says not responsive, or the documents that are most likely not applicable to this case. And that's a little under 700,000 as an example here, 695,000 and change. But finally, there'll be a certain percentage of documents that will just never be able to be classified. They're just so unrelated to any of the documents in the collection. And we'll go ahead and just have a manual workflow for those. So once all the documents have been classified, as we talked about before, we go ahead and we run a validation round, a sample round here. So we use a quality control round using a statistical sample and pull down documents from those buckets. We have humans go ahead and review those and say responsive, not responsive. The computer behind the scenes is measuring to see if the human agrees with the computer's decision. By understanding what that agreement rate is, we can project out or estimate out how many mistakes are in the overall universe. When we have the estimates of how many defects or mistakes are in the universe, when it's small enough, we can stop this entire process and say, hey, the computer's completely trained up, and I can make some big decisions here of what I want to review and what I don't want to review. So in this instance, let's just assume that there was too many mistakes in the system after one round, and we're going to continue and do this another round of this. So as I mentioned before, the computer learns from its mistakes. We retrain it. We're telling, hey, you made some mistakes here. This really is a relevant document. So we go ahead and tell it to reclassify now that it's learned some more. And it will bring back a report, and it will say, hey, Now I have 317,589 responsive documents because I've learned more about your case, because you've told me which ones I have mistakes on, which ones I'm correct on. And then it also will tell me how many not responsive documents I have. You can see the not responsive pile has gone down a little bit from 695,000 and change to 674,000 and change. So it's relearned, and you can see that it's shifted the classifications of the existing universe. So from here, again, we're going to sample from those buckets and have humans take a look to see how many mistakes are in the system. And again, the computer's measuring behind the scenes how many mistakes we uncover. And when the defects fit within the comfort level and what the review team has decided upon, we could say the validation criteria is met. And at that point, we could take a look at what's going to be in our next phase. So in our sample example here, humans have reviewed 9,000 documents manually. 990,000 and some change of documents were categorized automatically by relativity. We have 317,000 documents and some change that are able to go on to 100% human review. Humans will go ahead and review those 317,000. However, the 674,000 documents, you can make some decisions on. You can potentially decide to not review those documents, which would save you about 16,000 hours of potential review time. And if you translate that time into human cost, you can see that the value proposition of computer-assisted review combined with the statistical sampling workflow is quite strong. So let's kind of translate another kind of hypothetical into a return on investment. So let's see. Let's say we had 500,000 documents, and 35% of those documents are really what would be truly relevant to my case. You know, let's say the average reviewer goes through about 60 documents per hour, and we have two different categories of reviewers, or kind of our first-pass reviewers, which are a little bit less expensive. We have maybe a higher level reviewer that's a little bit more expensive. Maybe they know the case a little bit more. Let's say they're at $150 per hour. So if we're just to use brute force review, go doc to doc to doc using this review team, it would probably be around $1 million or so of actual cost if we measure by hour. If we use a computer-assisted review workflow using Relativity Assisted Review, and we take in some other factors such as how much it would cost perhaps to build that analytics index. Remember, there's that engine behind the scenes. Let's say there's some cost there. And let's say we have some variables we want to set as far as what is our review criteria, what is our sampling criteria. So in this instance, by using the computer-assisted review, we can save right off the top $200,000, a little under $200,000. But let's say we chose to not review those not responsives altogether. We'll put those aside and not review those. We would save, in that case, about $600,000. So you can see that it's a very, very strong return on investment on using computer-assisted review and still having the statistical sampling to back up the numbers as far as defensibility. This is the reason why I chose not to review those. Is this reasonable or not? And we can break down and show you a report of how you got to these numbers. So maybe we can just talk about some field stories, what we've seen in the field that's worked well on behalf of our clients. We recently had a client that had a large second request. So that's when the government asked for more supporting information between some kind of large transaction in the corporate space. So our client chose to not review 1.3 million documents after using the computer-assisted review. So huge amount of documents. By using this workflow, they were able to get comfort around not reviewing these documents by using the categorization, the classification technology, combined with our statistical sampling workflow. Next, we had a bankruptcy case. 2 million documents were categorized after reviewing just 1,500 documents. So you can see it does not take that many documents by humans to have the computer understand what types of documents we're looking for. Recently had a client that had civil litigation that had a compressed timeline. Another good use case of using this computer assisted review. Compressed timelines. How can I scale up while throwing as many humans? Sometimes it's just not possible. So they were able to review and produce out 200,000 documents in about 2 days. And finally, FCPA investigation. So this was FCPA is a Foreign Corruption Protection Act, and this was a review that was already had happened, and they had about 53,000 documents. And what they're saying is they took down a small sample of those documents, and which was less than 3%, and 97% of the documents were classified after just that first round of taking less than 3% of the population. And comparing the human coding to the computer classification based on the training, the computer system review agreed with the humans, or the humans agreed with the categorization 87% of the time, which sounds pretty impressive. However, you say, well, wait a second. What about that remaining 13%? The computer and the humans agreed 87% of the time. The 13%, man, the computer must have made a lot of mistakes there. Well, that's not necessarily the case. What we saw was that when they were doing the analysis, that 91% of the overturned documents were either exact duplicates or really conceptually similar. So what that's really saying is that the humans disagreed with themselves on the same types of documents. Two humans looked at the same document or similar document and had completely different opinions, which goes to show that the computer, it will be extremely consistent when it learns something. It'll either apply the same coding classification to a document consistently, correctly, or it'll make the same classification and coding call consistently wrong. One of the two. Which with humans, sometimes depending on the time of day, the things they've learned, all these different things, sometimes they change the coding and it's not as consistent. So bottom line, that 13%, the theory here is that the computer actually did a better job, more accurate job than the humans did on that remaining 13%. So where do we go from here? Everyone wants to talk about judicial approval in the system. Are courts going to allow this? And there's been a lot of press on this subject. Will judges accept this? Will lawyers accept this, etc.? And there's been some great articles lately, as well as some court cases that kind of been talking about this, contemplating it. Judge Grimm wrote an article just last year talking about this, and basically, if you look at kind of what's in bold there, he's contemplating, and along with his colleagues that helped write this article, that a party using advanced analytical software and linguistic tools and screen for privileged documents and work product may have found to have taken reasonable steps. So that's really what we're trying to do here with when we're looking through documents and we're going to producing party. It's not the quest for perfection. It's really, have we done a reasonable job? Have we taken reasonable steps? Have we thought through it? How is the process? If you just use a classification system without the sampling, is that reasonable? Probably not, because you really haven't determined how well you're doing. So he's contemplating in his article here that, in fact, that using analytical software is reasonable. And this is the one that is really recent, and many, many people are talking about it in the industry, where the magistrate judge, Peck, in the De Silva Publicis case, is basically saying that in this recent case, they used this computer-assisted review workflow, and he's saying that consider this judicial acceptance, that you don't have to be a guinea pig anymore, you don't have to be considered the first, that I've seen this technology, and I'm approving it for the court case that I'm presiding over. And what he's also saying here is that keywords, or even humans, are not perfection. They're not the gold standard. And this is a technology that he's actually asking people to consider when there comes to be large cases, because, as we talked about before, is extremely expensive and time-consuming for humans to look through all these documents, many of which are probably not really relevant to the case or the investigation. And so this got a lot of people talking, that we have a judge out there openly discussing and actually, in fact, ordering it in this case for the computer system review workflow to be utilized. So, Rich, from your perspective of big data, is this the topic that your viewers and your listeners contemplate and discuss?
Well, yeah, I think what's cool about this is an application. It gets more into specifics, and a lot of the big data discussions, Jay, that I'm in, they stay way up in the stratosphere, and it's all general, right? It doesn't. It just talks about, this industry could use it for X, right? Or they are using it for, like, Walmart. We know what they do with it, right? To make better decisions on stocking, etc. But here, it seems to me you've built what sounds like a competitive weapon for a law firm that could potentially, like, totally differentiate one firm from the other that would have this capability versus the doing it by hand. You think that's a fair description?
I do. If you think of a corporation, and you think about maybe the legal department. The legal department is in most cases it's not a profit center. They're not producing goods and services that benefits the enterprise. They're doing risk management, a really essential function. Don't get me wrong. And when you talk about the corporate data enterprise, their job is to make sure that all the content producers are able to create content and be able to maintain it, have disaster recovery protections, all sorts of different things that a modern enterprise needs today. If our data center goes down, do we have another data center that comes up? So we have kind of conflicting odds here, because we have this general counsel's office that has to manage risk, and there's probably maybe chief risk officers or chief compliance officers in addition to the general counsel. And then you have this other group, which is the chief information officer and the data center team that has to manage all this new data that comes in, and sometimes there's conflicting odds. And usually what happens is that the tie goes to the content creation, right? Because it's about business. We want to sell goods and services to our clients. And so the penalty for having all this is just so much data. And if there's an event that happens, it's just going to cost the enterprise much more because humans have to go through this and wade through it. So I like your point that this is a weapon. This allows the general counsels of corporations and the law firms to really combat this growing glut of big data, because they don't want to slow down an enterprise. An enterprise is about making money. It's about service and building wonderful goods and services for clients, and they don't want to get in the way of that. So this is a tool for them to wade through all these documents very, very fast, using computers and using modern technology that has been proven and used in the field.
So, Jay, it seems like we skipped a major step here, right? The curation of this. Right, think about, if you had millions of files at a big company, like, say, Oracle is suing Google, right, for Android infringement, right? So those data bits don't exist in one place, right? They're email files, they're documents, on and on, that are on different machines, different types of databases. All that in this scenario, doesn't that have to be collected and loaded onto a disk, and so that Relativity can go in there and start analyzing? Isn't that how the process works?
Sure. So Relativity is a web-based electronic discovery application that allows for a very efficient document review, doc review. And somehow we need to be pointed to where the documents reside. Somehow we need them. If Relativity is behind the firewall in the corporation, then there could be a workflow to get the documents into Relativity. But sometimes Relativity is not behind the corporate firewall, and someone does have to go out there and get the documents, and then be able to point Relativity to them so that people can start making document decisions. That's time-consuming as well. I mean, that's another issue with That's another issue with big data, is that big data equals big collection in many cases.
And from being a technologist, Jay, when you sit down to explain your value proposition for kCura and relativity, are you sitting across the aisle from a lawyer or their IT guys, or what's the typical scenario, and what are your challenges there?
Well, that's an excellent question. Um, Relativity helps solve and is a part of a solution set for legal and regulatory and commercial issues. And so our primary ultimate consumer are lawyers, are investigators. That's the ultimate consumer. However, the folks that make the buying decisions is usually a combination between the legal team, that needs to be able to has taste and preferences of the type of applications they want to work in and types of cases they work on. There is the IT team that has to make sure that any application that goes into their enterprise has to meet the security and other kind of technical requirements of their enterprise as well. So I don't want to punt on that question. It's really one of those, it depends. But again, the ultimate consumer is the attorney, the lawyer, or the investigator that has to go doc to doc on it. And it's really the IT team, as well as maybe the general counsel's office or outside counsel, that decides what tool to buy, if that's in case relativity.
And kind of a wrap-up question here, Jay. You're going after the legal market, but it would seem to me that the types of algorithms we're talking about here would have much wider applications, and you name it, oil and gas. I'm thinking of all kinds of scenarios. Are you looking at that, or licensing technology, that kind of thing?
Well, we believe that relativity can probably be a technology enabler for solutions in many, many areas and many, many industries. However, we are extremely focused on delivering software to this e-discovery market right now, really understanding what our customers do for a living and how they can use their tool, so we can really understand how they use it and empathize with them, empathize what they do for a living, understand how they work with the tool, and really make it the best possible experience in the e-discovery realm. Then we'll worry about some other industries.
Okay, Jay, fair enough. Well, hey, Jay Leib, I want to thank you once again for coming on the show today.
Thank you very much, Rich. I appreciate your time.
You bet. Okay, folks, that's it for the Rich Report. Stay tuned for more news and information on the world of big data.